There we go. So it says here, and I took this out of the book. Oh yeah. And this is kind of crazy, but this is it. The left axis is actually the expected value is actually the expected z-score for a percentile equal to this number. So the first order of business is to make these numbers. And then to find the expected z-score, you can look in the tables or use what's called inverse normal on your calculator. And we're going to see how that looks. And I'm going to try to use list arithmetic as much as I can. But first, we'll just look at if, say, the F1, say, was, pick a number, 0.273. We're going to get numbers like that, percentiles. Then we would come over to the table. I'm having a heart attack here. Here we go. So come over to the table, and we'd have to find 0.273 in here. So you could do it. I looked at the homework. I went, I'm not going to do that homework. It's just ridiculous. So we're looking at 0.273. Let me zoom in so I can see more. Okay. So 0.273. Here we go. There's 274, right? That's pretty close. About as close as you're going to get. And so the corresponding z value is minus 1.8. Where was I? 274. Sorry, 1.92. For 273, we're going to take minus 1.92. For example. And I really didn't want to mess with that, so there's a feature on your calculator that'll do that backwards z calculation for you. So we're going to take a look at that. Maybe here. Okay. And so if we go here, let's see, where is it now? Turn this on, clear this out. I'm thinking clearing, okay. And you go to, I think it's distribution. So you have to find that. There's a place to click that says distribution. Is it? I think it's down here someplace. Second distribution? No. Where is it? Well, I'll just zoom in so I can see it. Second distribution is near something.
It's by the VARS.
Up there somewhere? Oh, there, up here. Oh, I thought it was down here. I'm wrong. So second var. So second vars. Of course, I got on my. Here I am. I am now the human calculator. See that? My face is the calculator. Be careful what button you push. Anything could happen. Do not hit delete. Okay, I'm back here. Sorry. Couldn't help myself. Okay, so we're in there, and then we can go down here to this is inverse normal, number 3. And we hit enter. Okay, fine. And then it gives you the percentile. So I'm going to put in the 0.273 we just did, because we just did that one. And then we're doing standard normal. So mean is 0, sigma is 1. We're looking at the left tail. That's percentile uses the left side of the distribution. And then we hit on paste. Okay, this is sort of annoying, but see what happens. So it puts all the stuff into the inverse normal command. I guess there's probably a way to select it by typing it. I can't figure it out though. It says, look for the z value, because it's going backwards. Ordinarily, you would use the z value and look for proportions. This says, look for the z value for that proportion on the left-hand side of the value, if the mean is 0 and the standard deviation is 1. I hit enter. .273. I had 1.92. I must have been looking in the wrong place. Let's go back. Now I'm pissed. It says negative 0.6. Okay. It was 273. We're back here. I can't see, I guess. I did 0.273. Ha, ha, ha. Yeah. This goes to show you. I did 0.273. I want 273. I got to keep going until I hit the 2 sevens. Okay, 273 is between here and here. There's 274, that's off by 13. And that one, 273, that's off by 21. That's closer to 2743. So I got it wrong, minus 0.6, and that's O, right? Up there on top, I can't do it. Yeah, minus 0.60. No, this was 0.0273. So we get negative 0.60. And then sure enough, it matches what's on the calculator. I just double check things because for that exact reason, it's easy to look stuff up wrong. Okay. So that's the calculator version, certainly simpler and faster, especially since we have to do it 100 times. So we're ready to do it now. So probably won't mess it up. Okay, so we're going to fill out a table that looks like this. This is the plan. You take the data and you put it in order because the formula says, this formula we're using here is the percentile for that ith data value. So I equals 1 is the smallest value. Then I equals 10, 12 here. 12 would be the largest value. N is 12. So we're going to compute all these numbers, all these percentiles for each of them. And so first of all, I put the data in order. So, but I'm going to do it here too because I'm going to have to use this. So stat, edit. Okay, so I'm going to imitate what's on the screen here in my calculator. So I already typed stuff, but too bad, clear. Okay, so on the left-hand side, I'm going to go 1, 2, 3. What happened here? I typed wrong. There's 12 of them. That's funny. 11, 12. Okay, I'm in trouble now. I missed a value even. Let's see what I did wrong. I missed my 10. Haha, 10's on top. That's annoying. 10, 12, 14, 16, 17, 19, 21, 24, 28, 37, 45. Except I want them in order. 32, 37, 45. Okay, so that's all crazy. And so now I've got the data in order. This is the I value, 1 through 12. I'm typing them here. So the calculator will be clean. My paper is going to be ugly. Okay. So there's the value. There's the row numbers, or now the data. Okay, just look at that. There's 12 of them, 45, 37, 32, 28, 24, 21. I think I'm okay. And then I want to stick all these values here in this column. And I'm going to do it using list arithmetic. So I'm going to get out of here, make sure everything's okay. Looks all right. I'm going to quit this. Then I want to make this formula happen. So I need the row number, which is in list 1. So I go second 1. I need parentheses. Wait a minute. Parentheses, second 1. So that'll give me this I number. It's going to pull it off the first row, first column. And a minus 0.375, like that. That's the top. And divided by, N was 12, a plus 0.25, like that. So that'll do that calculation. And then I want to store it in this third. So this is L1 sitting here. I wrote 2, L1, L2. I'll make this L3, like that. So go ahead and store it. So the store button's down here, store it. I hit that. And I'm going to store it in list 3. That's where I want it, second 3. Okay. So we'll go look at it. So those would be where you'd expect to see in terms of percentiles. The smallest value should be about the 5th percentile. And then as you work your way down, the percentiles go up. The second smallest, the 13th, and so on. until you get up to the top one. It's at the 95th percentile. That's what happens with 12 values with normal distribution. So we're not quite a normal distribution set. We're dividing the positions into 12 spots. And those are the corresponding percentiles. Have to not worry about it too much because the strategy behind it is quite complicated. But I'm going to, do I want to write them down? I really don't. I'll put some in there. This is hard to do because if you're right-handed and you're writing backwards, it's not fun. Okay, so this is 0.051, and this is 0.1327, and it continues on 0.2143. And then at the bottom there, we don't need these exact values. So at the bottom, it's 949, and then it's 0.8673. So I want to put over here in this list, second list, that the expected value, this is going to be the expected z. I'm going to put list 4 here. And you can't do a list arithmetic to make that happen. So it's just going to be annoying. I'm going to come up here. I'm going to clear that list. Okay. And first we'll just do a calculation. So what goes over here in this first spot is inverse normal of that. We'll just do that. I try to do the whole list at once, but it won't accept it. Okay, so we quit this. Or can we just go straight there? I'm going second distribution. I'm leaving my cursor there. See what happens. I'm going to go inverse normal. I'm going to hit enter. Now I'm going 0.051 like that. And then we're going to go down, down, down to paste. And it's going to paste it into that exact spot. That's the hope. So there's that negative 1.635 we wanted. Okay, so now I just have to do that 11 more times successfully. I go second distribution, inverse normal, go. Now I'm going to type in, oh, I see, it's going to be gone in a minute. You may have to help me. 0.1327, down, 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 enter, enter. Okay, negative 1.114. Then do it again, second distribution, go down, enter, 0.2143, down, 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 paste, paste, okay. Negative 0.792, like that. So now I need some more help. Can someone, the next one corresponds to 2959. Can somebody give me the number that goes here? I will talk to, someone have it already?
Yeah, I have negative 0.5362.
Thank you. And I'll just, should I type it? Negative 0.5362, okay. And then we're looking at 3776. Any other volunteers?
I got negative 0.31179, blah, blah, blah.
7, like that? And the next one is, oh, put it in. 0.3117, okay. Then I'm at 4592.
Negative 0.1025.
It's rounding it, isn't it? I didn't type 3, did I? I don't think I did. Yeah, it's only keeping 3 places. That's okay. The calculator has more. It's just only showing 3. And now 0.5408. Now we should get positive numbers because we're past a half.
I got 0.1024.
Okay, and then so we ought to see these same numbers with positive signs now. 6224.
0.31192.
So there's some small amount of maybe rounding happening, but they're about the same numbers. Okay. And then I didn't type it. 0.31192, it'll round it. Okay. And then it's 0.70441. Yeah. 0.7041. Uh-oh, ran out of help.
I got 0.53617.
Okay, there's just a few left.
For the next one, I got 0.79162.
Oh, 0.79162, okay. We're almost at the end.
$1.1137.
I keep looking up here and seeing if it's about the same number, right? Pretty much working out. And we got one left. Is that for the 8, 6, 7? I think it is, okay. Okay, we're at the last value. So we should get 1.635 approximately.
Yeah, that's what I got.
Okay, we did the task. Wasn't too bad. You can imagine looking those up in the tables. I can't. I would not want to do it. So that's on the homework. That's what they suggest. I go, no, that's not going to work for me. That's certainly not going to. They just won't do it. I wouldn't do it. Okay. And so now we want to make the plot. So the plot here. So the normal plot puts the data values against their expected z positions. So we're going to plot. We're going to do a plot of L4. This is x then, and this will be y. So x will be in L2 and y will be L4. Okay, so I'm going to go to stat plot. So stat, just go straight to stat, I guess. No, stat plot, second stat plot. There we go. And then I'm going to go and I'm at plot 1, right? I'm going to take plot 1. I'm going to turn it off. Okay. And then I'm going to go up there and pick plot 2 and turn it on. And then I have to pick the kind of plot. Let me zoom in so I can see what I'm doing. So you have choices there for type of plot. The first one is a scatter plot. The second one is a scatter plot with the dots connected. The third one is a histogram. The fourth one is a box plot with outliers indicated. The fifth one is a box plot. The last one's normal probability plot. And if we just had the data, we would do that. We now created the values for the probability plot. So I'm going to select that one. That'll make a scatter plot. And then the X list is L2. Second 2, okay. And then the Y plot, the Y is in L4. That should be right. Now, if we did it right, we should get that nice, gentle rising curve. I'm scared. Should I just push graph and just not worry about it? Okay, here goes, boom. Oh, I'm scared now. What happened? Stat. Edit. So it says list 2. Did I pick list 2? List 2. And list 4. Oh, I forgot to type the last number. It said they had a dimension mismatch means there's not the same number of elements in each list. And so the last number was 1.635. Yeah, that's not point. Okay, so now that's good. I'll go back to graph. Cool. So there's that same picture that we just got before by going straight to stat plot. We just created all the values, as annoying as it was. And there's a reason for creating the values. We'll see what that is in a second. But I was happy this worked. So that's exactly what the calculator is doing. In fact, we could trace this. We'd find, I hope, the same exact numbers. So that's that negative 1.635 we saw. I think they're exactly the same numbers, 1.1. I'm hoping they're doing it. This is the accepted procedure. There's a couple of procedures that are quite a bit like it. This is the most widely used procedure for making normal probability plots. There's more than one though. So we did that. We made the plot. Okay, now what? Okay, so it says here, now we can construct the plot. Did that. Yay. It looks like this. Okay. And I'm going to stop recording for a second.